Hello scholars! Go ahead and work on the do now, pause the video, and play it when you're ready to go over the problems. Okay, the first one here, I'm just checking that you remember the concept of dominance. Okay, so in this AP problem, they give you a limit as x approaches infinity of x to the third divided by e to the 3x. Now, first thing you're going to think is, can I plug in infinity? No. Then your next best bet is deciding, is the numerator or denominator greater? We know that the exponential function is always greater than the polynomial function. So the denominator is greater. We're going to write that down. Denominator is greater. And if you forgot, then you can pretend that you have a fraction, let's say 1 over 200,000. You're going to think, is this a really large number or a really small number? This is a small number. Hence, eventually, as the denominator gets bigger and bigger and bigger, your limit will be 0. For the next one, you have a piecewise function. Then it says, if f is a function defined above, then f prime of -1 is. So don't fret, all we need to do is get the derivative of each piece. So derivative of 3x plus 5 is 3 when x less than -1. Negative x squared plus 3 is -2x when x is greater than or equal to -1. So if I'm trying to evaluate at -1, I will choose the second function. Now you need to make sure that you understand why we chose the second function. So pause the video, go back, make sure you're discussing with someone, and just so everyone remembers, x smaller than -1 means -2, -3, etc. X greater than -1 means -1, 0, 1, 2, 3. And since our x value is found in the domain of the second piece, then we use the second function. Alright, for linearization, tangent line, linear approximation, what we need to remember mainly is y. Well, let's not use y2. So let's just use y minus y1 equals the slope m times x minus x1. This is the main formula that we have to use. And if you want a visual of what linearization is, let's say we have a curve, and given any point, let's say this point right here, linearization at this point means we're going to make a line, okay, and this line has this formula, and we're going to use this line to approximate the y values of the function. Meaning it's not exact because obviously the line is not the same shape as the curve, but if the curve is too hard to work with, we use this line to approximate what's happening in the function. So that's what linearization is. Okay, so let f be the function defined by f of x equals 4x to the third minus 5x plus 3. Which of the following is an equation of the line tangent to the graph of f at the point when x equals -1. So a few things. When you see the word equation, they're looking for this setup. Okay? So you're going to have a y minus y1 equals m times x minus x1. A few things here. X equals -1, they give you, okay, and that goes into x1. So that's going to be -1. Now we need an m, and we need a y1. Let's start with y1. If we have the function f of x, and we know that x is -1, how do we find y? Well, we just plug in -1 for every x that we see. And let me just fix this here. Just to be clear, it's x minus -1 over there. Alright, so I'm going to plug in -1 and solve. That's going to be 4 times negative 1 plus 5 plus 3. It's going to be negative 4 plus 8. That's going to be 4. So this is my y1. That's going to go into here. So I have 4. Y minus 4 equals. And now for the m. So the m is super important. M is slope. And we know that in calculus, the slope is also the derivative. So the slope at a very specific point is the derivative. So what we're going to do is take the derivative of f of x. I'm going to write it here. So it's going to be 3 times 4 will be 12, x squared minus 5. And then we have to evaluate it at the point that we're looking at. Well, we're looking at x equals negative 1. So we're going to plug in negative 1. (12 minus 5 will give us 7. And that is my slope. So take a minute, make sure you know where all the pieces come from. Now if I simplify this, y minus 4 equals 7, x plus 1. I don't see the match in my multiple choice, so I need to work a little bit to make it look like one of the multiple choice options. Well, this part is the algebra, so I'm going to distribute the 7. I'm going to add the 4. And then I have 7x plus 11. This means that at the point negative 1, comma 4, let's pretend that this is the curve. Negative 1 comma 4 might be right here. If I drew a line tangent to that dot, then this line has the equation y equals 7x plus 11. Okay, number 24. So it says the function f is twice differentiable with f of 2 equals 1, meaning 2 comma 1. F prime of 2 equals 4, so this is for the derivative, 2 comma 4. And the second derivative, they give us something here. That's going to be 2 comma 3. So we have a few information. What is the value of the approximation of f of 1.9 using the line tangent to the graph of f at x equals 2? A few things here. You see this decimal point here? Don't worry about that till the end. First, let's make the equation. And we know the setup is y minus y1 equals m times x minus x1. We know that 2 goes into x1, so that is completed. Now, we don't know m yet, but we don't know m yet, so we're going to leave that, but we know y1. Okay? So that means, what is the y value when x is 2? Let's look at the information they gave us. They gave us this info right here for the original function. When x is 2, y is 1. So 1 is going to go for y1. Now for m, we know that m is slope, and which is the derivative at x equals 2. Well, hold up. Don't they give us to us as well? Right here. So when x equals 2, the slope is 4. And we have an equation. Perfect. Now you have to start looking at what the question is asking. So I'm going to rewrite the equation over here. And it says, well, what's f of 1.9? All this means is that x is 1.9, and I'm going to plug this in. Plug into the equation. Let's go ahead and do that. Sweet. So now all we have to do is solve for y. So 1.9 minus 2 is going to be negative 0.1. And then if you times 4 times negative 0.1, you're going to get negative 0.4. Then we're going to add 1 to both sides. And y is going to be 0.6. Perfect. So just to confirm, we did not use the information about the second derivative, and that's okay. Okay, so that's just extra information that was given to us, but we did not need to use it. Okay, let's move on to number 18. Okay, in the xy plane, the line x plus y equals k, where k is a constant, meaning k is a number, is tangent to the graph of y equals x squared plus 3x plus 1. What is the value of k? So here, one thing we need to do is to remind ourselves that what this is saying is they have the same slope. So they have equal derivatives. Alright? So, let's do it. X plus y equals k. Well, I don't like seeing it this way, so I'm going to subtract x from both sides so I can get y by itself. And then we also have y equals x squared plus 3x plus 1. If we take the derivative of both, y prime is negative 1 because k becomes 0. Okay, and then y prime here will be 2x plus 3. Now I can set them equal to each other. Subtract 3. So x is negative 2. Alright, we're close, but not quite there yet. Okay, so we have the x, but really what we're looking for is the k. So we have something to plug in for x, if I rewrite my equation here. But we're not done because we need something to plug in for y, so we can figure out what k is. Easy. Let's use this equation to plug in x. Which will give us y. So it'll be 4 minus 6 plus 1, negative 2 plus 1, negative 1. So this will be y. Okay? I'm sorry, so x should be negative 2. So if I add them, it becomes negative 3, so k has to be negative 3. Okay, for number 26. Perfect. So arctan, just a quick recap, is the same as tangent inverse of x. And the derivative of that is 1 over 1 plus x squared. Okay, so what is the slope, so meaning the m, of the line tangent to the curve, at the point at which x equals 1/4. And I just want to I underline slope here because if you notice, they're not asking for the equation of the tangent line. They're just asking for the slope. So we need to get the slope, which is the derivative at x equals 4 of y equals arctan of 4x. So let's get the derivative of arctan. So first, arctan is the same as tangent inverse of 4x. So let's get to work. It'll be 1 over 1 plus, instead of just x, we have 4x to the second power, times the derivative of the function inside the parentheses. Derivative of 4x is 4. So if I simplify this, it'll be 4 over 1 plus 16x squared. This is y prime. Now I need to plug in 1/4. So it will be 4 over 1 plus 16 1/4 squared, which will be 4 over 1 plus 16 times 1 over 16, which will cancel.